af- Good afternoon, class. Can someone lead us in out of prayer? Just put up your hand. Anyone to lead us, please raise your hand such that we can request you to pray.
Guten. Guten.
Lynette, please mute your mic. Only unmute when you want to choose someone to say something. Yes, Alden.
Let's humble ourselves. Oh, Heavenly Father, God above, we thank you for bringing us here with your love. We thank you, Lord, for wonderful school. We thank you, Lord, for everyday food. Protect us from harm. Protect our parents and teachers from harm. With your loving will, we thank you, Lord. Amen.
Amen. Thank you. Okay, so I want to quickly share with us today's devotion before we begin our chemistry lesson. It says, create what you want. Create what you want. Hebrews 11:3 says, by faith we understand that the worlds were framed by the word of God, so that the things which are seen were not made of things which are seen. God created the whole world with words. He spoke and everything came into being. Guess what? You can do the same because you're made like Him. When things don't seem to go right, that's not the time to cry or complain. Rather, speak God's word. If you feel any symptoms in your body, say, I am strong and healthy in Jesus' name. Refuse to speak fear or doubt. Say only what God has said about you. That's what faith does. God wants you to say what you want to see. Just like He spoke light, life, and beauty into the world, you can speak peace into your home, joy into your day, and success into everything you do. That's how to live by faith and create what you want. Mark 11:23 says, for verily I say unto you, that whatsoever ye shall say unto this mountain, be thou removed and be cast into the sea, and shall not doubt in his heart, but shall believe that those things which he saith shall come to pass. He shall have whatsoever he saith. Let's kindly take on the prayer after me. The Holy Spirit makes my words powerful and full of life. With my words, I create a beautiful life filled with peace, joy, and God's glory every day. In Jesus' name, amen. Thank you for listening. All right, so we are going to continue from where we stopped. But before we do that, can someone remind us what we looked at last week? What are some of the things you remember in last week's lesson? Yes, Lynette, you can unmute.
Teacher, we stopped on the table of alkanes. Alkanes.
Okay, thank you, Lynette. Who else? Can you please share? Can see in the chat carbon in life, alkanes. Okay, compounds. Anyone else? What do you remember in last week's lesson? I'm seeing alkanes and their molecular structure. Okay, that is good. So basically, we were looking at carbon in life, where we started on alkanes as one of the homologous series in that chapter. So we are going to continue from there. Because I left us an assignment and I think it's only about 5 people that handed in the assignment. I don't know the rest if we didn't do it or we just didn't feel it important to hand in. But at least I received some people's work and I was able to mark it. So we'll just begin from that part where we stopped. Yeah, this is good. Venus, a carbon atom can form only 4 bonds. That is very important for us to note. So what was the name of the first alkane that we formed? What was the name? Who remembers the name of the first alkane that we formed? Okay, I'm seeing methane. Very good. So we said the first one is methane. What was the name of the second alkane that we formed?
Then
Ethane. So we had ethane. Then what was the third one?
propane.
Propane. What was the fourth one? People, you can
Butane.
raise your hands because I don't expect Lynette to give all the answers. Butane. And then
Then
what was the
then
fifth one? We'll stop on the
then
fifth one for now. Venus,
Pentane.
pentane.
wekemo kun. Mshore mukae mzokuzana na imwe.
Lynette, we already agreed. If you're going to talk, please mute your mic because your feedback in the background keeps coming to us. So keep your mic muted unless you want to say something. You unmute, then mute again. I requested if you knew the duties of a co-host. Because if you don't, then I could take you through. It's important to have the lesson flow without interruptions. Okay, so we have these were basically the ones. Then I told you to find out the names of the ones that were 6, 7, and 8, and 9, and 10. And I was saying some people handed in, but we are about 90 here. The rest didn't hand in. It was about 10 people who handed in. So ask yourself if you're actually among the 10 that handed in. So here we are going to look at the general formula of these alkanes, because we now know that if we have an alkane, we just need to know how many carbon compounds, how many carbon atoms does it have, so that we give it a name that aligns with its alkane character. So that means if we have carbon, one carbon, we said it's methane. If we have 2 carbon atoms, that is ethane. If we have 3 carbon atoms, that is propane. If we have 4 carbon atoms, that is butane. If we have 5 carbon atoms, that is pentane. So when you look at these carbon atoms, you realize that the hydrogen atoms are depending on those carbon atoms. So that means we are going to say if we have n carbon atoms, how many hydrogen atoms are we going to have? Anyone to quickly think about that? If we have n carbon atoms, how many hydrogen atoms are we going to have? Anyone, you can put up your hand. If we have n carbon atoms, how many hydrogen atoms are we going to have in any alkane compound? If we have n carbon atoms, how many hydrogen atoms are we going to have? Okay, I'm seeing some answers as 4n. Let's first try out and see if we had 4n here. So if we look at methane, we have C1. If we have one carbon atom, that means you're going to have C1H4 times 1, which will give us CH4. Then if we have ethane, if we have two carbon atoms, that means we have C4 times 2 is going to give us C2H8. Then if we have three carbon atoms, we are going to have 4 times 3 to give us C3H12. Atoms, it's going to give us 4 times 4, which gives us 16. It's 16. Do we agree by this method of 4n? Do we agree by the method of 4n? Because it looks like some carbon atoms are there. It looks like some of them are excess. Because now when you look at propane, and then when you look at butane, they have 16 hydrogen atoms. Where are we going to put those 16 hydrogen atoms? Where are they going to go? So can we suggest another way we can find those? I'm seeing 2n. I'm lost. I've not understood. My question was, I know we are all mathematicians here. If we have n carbon atoms in our structure, how many hydrogen atoms are we going to have in that particular structure? And then, of course, someone suggested 4n, and I said, if we have 4n, if we have the number of carbon atoms as n, and we have the hydrogen atoms as 4n, will it give us the structure that we are looking for? Because if it's a general formula, that means if I use it, it should be able to give me any alkane. So that means if I have n is equal to 1, and I have my one carbon atom, that means I'm going to have H 4 times 1, because we said 4n. So that means the value of carbon atoms here is the one we multiply with to get the number of hydrogen atoms. So I am saying the formula we've got for propane and for butane, they seem to be different. So are we still saying that those are the carbon atoms we are going to have? Gravely, thank you. So you realize that this formula is not going to work for us. It's not going to be able to give us the number of carbon atoms we are looking for. So that means we are going to use Gravy's answer, which says that we have 2n plus 2. So if we have 2n plus 2, we are going to still try out and see such that we get the formula of each of those carbon compounds. So that you're going to have, if n is equal to 1, that means if we have the number of carbon atoms as 1, that means we are going to have H, which is 2 times 1 plus 2. So this is going to give us CH4. Then we go to ethane. Ethane has 2 carbon atoms. If N is 2, that means we are going to have H 2 times 2 plus 2, which is going to give us C2. 2 times 2 is 4 plus 2 is 6. Then we have, if we have 3 carbon atoms, that means we have 3 carbon atoms. 2 times 3 plus 2, that is going to give us C3H. This is 6 plus 2, which gives us 8. Then we go to C4H, 2 times 4 plus 2. That is going to give us C4H8. Sorry, 8 here plus 2, which gives us 10. So you realize that this formula aligns with the structures that we got last week. So if you wrote down, realize that if we use this formula, it will be able to give us any alkane that we want. So you're going to prove the one for pentane. Find out if the one for pentane using this general formula will give you that answer, the same as the one we have here. Find out if you use this general formula to find out the formula of pentane, if it will still give you the one that we wrote while beginning our lesson. Is that what we get? Okay, I'm seeing it works. From Davis, NBA. Okay. So that is basically how we find out the general formula of those. Grace, no, that is wrong. H stands for hydrogen. At least by now, if you attended our previous lesson, you should know what H is. Because we said alkanes are hydrocarbons. That means they contain carbon and hydrogen atoms only. So C stands for carbon, H stands for hydrogen. So that is how we categorize them. That's why I said if we have the number of carbon atoms as N, how can we get the number of hydrogen atoms? Because remember, the hydrogen atoms increase with increase in the number of carbon atoms. But when you look at these ones here, you're going to notice that the carbon atoms are increasing by 1. But what about the hydrogen atoms, sorry. So when you look at the hydrogen, you're going to notice that they are increasing by which number? When you look at hydrogen atoms of these 5 alkanes, by which number are they increasing? By 2, very good. So that means if they're increasing by 2, that means we have already a certain number. That's why we have these 2 here, to tell us that for every hydrogen atom you're going to go to, you're going to increase it by what? By 2. That's why we have 2n plus 2. Because to move to the next alkane, you're increasing the number of hydrogens by 2, depending on the first original one. Because now for us to get methane, you had to have Cn plus 2H, 2N plus 2. So that means if carbon had 1 atom, we have 1, then that means the H is 2 times 1 plus 2, which is going to give us C2H4. Like I said, sorry, C1H4. Like I said, when it comes to these chemical compounds or chemical formulae, the general formulae of these families of homologous series, you're going to notice that I told you last week that if you have an area of a square, no matter how big that square is, no matter how small it is, you will use S times S. So it's the same thing for alkanes. Instead of you writing this whole thing, yet you want the formula for pentane, you can just feed into this general formula and you say pentane has 5 carbon atoms. That means if I have 5 carbon atoms, I'm going to have 2 times 5 plus 2 to give me the number of hydrogen atoms. So basically that's why we need the general formula, but you have to study the trend. That's why we had to first know what is methane, what is propane, what is all the others, such that we generate the general formula. I hope that is clear, even for the ones that were saying they are lost. Okay, so I'm moving on. So this is the question we're answering. What is the general formula of alkanes? And we've said the general formula is CnH2n plus 2. So that is the general formula of finding alkanes. Then develop a model of alkanes using the available resources in your environment. So this one you will need to develop your own model of alkanes. So for example, maybe you can get any round crop and then you're able to make maybe butane. And then you just do that. You just get sticks, you join them, then you have a different color representing hydrogen. So you can get 2 rounded balls of different colors, of different kinds. Then of course you get 4 to represent carbon, then 10 to represent the hydrogen. Then you're able to work around them. Then you just create your model depending on how it is. Or you can even Google and see what models have been made. Then you improve yours in alignment with that one. Okay, so we are going to move on to the next part. And the next part is about physical properties of alkanes. So I'm going to request us to share some of the physical properties of alkanes that we know. You can raise your hand, we'll ask you to unmute, then you share with us. Which physical properties of alkanes do you know? Yes, Isabella.
The first four alkanes. The first four alkanes are gases, while the rest are solids.
Okay, thank you. The first 4 alkanes are gases. Are they the rest, are they solids or liquids? Which ones are they? They are less dense than water. Yes, Alden.
They are insoluble in water but soluble in organic solvents.
Okay, very good. They are soluble
In water but
in water.
soluble in organic solvents.
Okay, that is good. Lynette? Lynette, are you there? Please unmute and say what you want to say. Okay, let's hear from Niva.
They have a low melting and boiling point due to weak intermolecular forces.
Okay, though we'll need to improve that, but thank you. Franklin? Victor, sorry.
They have their melting points and boiling points increase with molecular size because the van der Waals forces get stronger, requiring more energy to overcome.
Okay, that is good, thank you. Prissy? Prissy? Okay, Tony?
They are
Swalba?
They are color.
Yeah, colorless, okay. NBA?
They are odorless.
Yeah, odorless. Okay, thank you. Okay, so I think we could look at those for now. I'm seeing in the chart they contain electrical conductivity. I didn't get that. They are colorless, they are insoluble, increase with chain length, lower are gases, then medium are liquids, and then higher members are solids. That's good. They contain carbon and hydrogen compounds. They contain hydrogen and carbon atoms, not compounds. Please correct that. Thank you all for your submissions. The person saying, pardon the question, I asked for physical properties of alkanes. So when we are looking at boiling and melting point, we are basically looking at, if you're looking at the boiling and melting point of these alkanes, you're going to notice something that as the chain increases, the boiling and melting point also increase. Because the more the number of carbon atoms in that given compound, you're going to notice that it requires a lot of energy to overcome those intermolecular forces or the van der Waals forces of attraction. So in order to overcome those forces, you will need more energy in order to overcome them. Not energy of carrying them, but the energy of breaking the bonds between them. So that means in that case, as the carbon atom chain increases, the melting and boiling point also increases. That's why we say that melting and boiling point increase with increase in molecular formula or molecular size. Because we know that if the chain is increasing, that means there are more atoms involved, and that makes the atom to become not big like in how you see it, but in the number of atoms, it will seem big because the atoms are many and the chain is long. Or even when it's branched off, you realize that it requires energy. So we have a diagram here that I want us to look at. So we have this graph here. The orange line, I don't know if it's orange or red. The orange line is showing boiling point, while the blue line is showing melting point. But you're going to notice something about this graph. You're going to notice that there is that steady increase in both graphs because of the increase in the number of carbon atoms. So these small figures here are showing 1, 2, 3, 4, 5, 6, 7, 8 are showing the number of carbon atoms in that particular compound. So that means we have 1, we have 2, we have 3, we have 4, we have 5, we have 6, we have 7, we have 8, we have 9, we have 10, 11, 12, 13, 14, 15, and then 16. So that is showing us the number of carbon atoms. For example, this first one is again, the third one is propane, the fourth one is butane, and so on and so forth. So it is showing you that there is that general increase in boiling point and melting point of these given alkanes because of the increase in the number of carbon atoms. So I hope that is clear. Even when you're explaining, you should be able to understand where that is coming from. Okay, so moving on to the next part. Why do melting points and boiling points of alkanes vary with the number of carbon atoms? I think I've answered that. I'm going to request someone to put up their hand and they read for us the answer, since I've already explained why they increase that way. So I just need someone, you put up your hand, you read for us that answer. Yes, Lynette.
Melting and boiling points increase with increase in molecular mass since the van der Waals forces increase.
Okay, thank you so much. So that means boiling and melting points increase with increase in molecular mass, since the van der Waals forces of attraction increase. And I've explained that molecular mass increases because if the carbon atoms are more, that means the hydrogen atoms are also going to be more. So that makes the atom big in mass, not like in carrying it, or like you're seeing it and you're saying, oh, that rock is big. No. But like if we look at its molecular mass, it will have increased. And I know you will relate with this better when we get to the next topic that you're supposed to cover in senior 3. Okay, so we have identify and explain other physical properties, and we've already said them, so I'm going to just display the ones I have here. Can I have someone to read them for us? Please put up your hand such that you can read for us those properties. Yes, Stella?
Alkaline,
Alkanes.
alkanes are colorless and odorless. Alkanes have 1 to 4 carbon atoms are gases, 5 to 17 carbon atoms are liquid, and 18 or more carbon atoms are solid. Alkanes are insoluble in water and soluble in organic solvents such as benzene. Density increases with increase in molecular mass, but branching reduces this strength.
Okay, thank you so much, Stella. So some of the other physical properties that we have, of course, physical properties involve you touching, smelling, or even seeing those things. So that is what we call physical properties. So, of course, when we boil them, we are able to see that there is an increase in boiling point by using a thermometer. There is a decrease in melting point, like that. So that is basically what we use. And I have said, when you look at these carbon hydrogen compounds, They are held by those weak van der Waals forces. But the more the chain increases, the more these forces also increase. So that's why we said boiling point increases with increase in molecular mass, since the van der Waals forces of attraction increase. Then the other properties we have, alkanes are colorless, they are odorless, and then of course someone already mentioned alkanes which have 1 to 4 carbon atoms are gases. That means methane, ethane, propane, and butane are gases. Then from 5 to 17 carbon atoms, they are liquids. Then 18 to more, because of how lengthy they have become, these ones are solids. Then alkanes are insoluble in water, like someone already mentioned, and they are soluble in organic solvents. The reason why these alkanes are soluble in organic solvents, because they are also organic solvents. So the organic solvents are going to dissolve in fellow organic solvents, for example, benzene. So that is how basically you could look at that, but they are insoluble in water. That means they cannot dissolve in water. Then density, of course, will increase with the increase in the molecular mass. But branching reduces this trend. We know that if something is so long, it will eventually branch. So it's the same thing. When we have very long alkanes, you're going to find that there is branching that reduces the density. But otherwise, density increases with increase in molecular mass. Dennis, do you have a question? Because your hand is still up. And Stella. If you don't have a question, please put your hands down. Elvis? Elvis, I can't hear anything from your end. Okay, it seems you don't want to talk. Let's hear from someone else. Akij or Akijab, I don't know. Okay, I also can't hear you. I don't know if it's on my end. Hey, XD. No, I am not going to demonstrate branching. Reason being, it's not at our level for now. So I am not going to demonstrate it, because if these concepts that we are learning are still giving us hard time, then I can't dare go into branching. So if you want branching, do it on your own research, such that I don't confuse people who are trying to get what we have here. But like I have said, if something is so long, you're going to notice that you will need to branch if where you're going has stopped. So it's the same thing with branching. You will need to demonstrate that kind of branching. That is enough for us to understand for this level. If you want to understand more, please go and research. But otherwise, I cannot explain it here, because people will get confused and I'll need to go into more details of things. So just understand what we are learning now and take that for that. Okay, the people that are putting up their hands, I don't know if they have questions, because when I ask you to unmute, you just keep quiet. Let's hear from Cave. Cave, you can unmute. Sorry. Okay, anyway, let's continue. So, so the person asking the difference between alkanes and alkenes, we've not yet looked at alkenes, so I don't know why you're asking for the difference between the two. Let's first understand what we have here, because looking at some people, they have not understood this, but their questions they're asking are even greater than what they haven't understood. So let's concentrate on what we have here. Ask questions that are about this part here. Then I have emphasized that density increases. If you say it increases with increase in molecular mass, that means the more the carbon atoms increase, the more the density will increase. Because we have said these alkanes can go even up to carbon 20. So if they have carbon 20, that means the hydrogen atoms are going to be 20 times 2 plus 2. So that is going to give us carbon 20. This is 40, that means hydrogen 42. That means this chain is long. So since it is long, we cannot write it the same way we've been writing propane like this. Because propane, for it, we can just write this and put our hydrogen atoms and we go and do other things. But when it comes to 20 carbon atoms, it requires you a lot of patience to really write all those things. So you're going to find that because of that, it's going to branch off. It's going to create branches here. For example, where you are seeing hydrogen, you're going to find that maybe there is another carbon such that the density reduces. So that means the higher the molecular mass, the higher the density. So basically, that is what that point means for that person who wanted me to repeat that part. Van der Waals forces, I already said they are weak forces. Please note down the things we are sharing. Otherwise, you're going to keep asking the questions of the things I have already explained. And we will be boring those people that have already understood and noted down the points. I said when you look at these carbon atoms, you realize that they are held by certain forces. The forces holding those carbon atoms together. So the force holding this carbon atom here, let me use another color, holding this carbon atom here to this carbon atom to this carbon atom, those are the ones we call weak van der Waals forces. So these forces, the bonds that are created, are held by forces. So those forces keep them together. And those weak van der Waals forces are mainly found in nonmetals. So you find that there are those weak van der Waals forces holding those carbon atoms together. So in order to break them, it requires a short chain for you to take less heat in order to overcome those bonds. So that means in that case, for propane, you will have a low melting and boiling point. But when it comes to hexane, you're going to have a high boiling and melting point than the one of propane. And that's what we were showing here. That's why you're seeing in this table, the previous table we had. And this is the last part I'm explaining such that we move to the next thing. So, let me first go back briefly to the last slide. So when you look at this graph here, I told you that these 1, 2, 3, 4, 5 are representing the number of carbon atoms. That means the number of carbon atoms is increasing, and this side here is representing the boiling and melting point. And I told us the orange line is representing the boiling point, while the blue line is representing the melting point. So that means in that case, the more the carbon atoms increase, because they're the ones being held by the weak van der Waals forces, the more they increase, that means the higher the boiling point and melting point is going to become. So that's why you see that on both graphs, the lines are increasing. So I hope at least that should be able to clear the air for some of you. Okay, so this table here is basically showing us the different alkanes, their boiling points and their melting points. Assumpta, you'll be fine. Maybe you'll have to go back and watch this video. Then Myra, if you've been following our lesson, I don't know why you're lost. So for those who haven't understood, please, this video will be posted in the group. So go and watch it such that you understand. Otherwise, I apologize. We need to move on. So anyway, so when we are looking at this table here, it's showing the different boiling points and melting points of different substances. So you're going to notice methane has a boiling point of this and melting point of this. So you're going to realize that the melting point here is increasing as you increase the number of carbon atoms. So for example, here you realize that we have 1 carbon atom and 4 hydrogens. We have 2 carbon atoms and 6 hydrogens. We have 3 carbon atoms and 10 hydrogens. We have 4 carbon atoms and 10 hydrogens. So like that, you realize that the melting point and boiling points increase. So the melting point here, you realize that there are those smaller figures. Those smaller figures with we know that if a negative is smaller, it is bigger than the negative that is higher. So for example, if you're comparing negative 183 degrees Celsius and negative 30 degrees Celsius, you realize that 30 degrees is bigger than negative 180. So that means the smaller negative represents a bigger value than the bigger negative. So that's why I'm saying that for melting point, there is an increase as you increase the number of carbon atoms. Then for boiling point, still the same thing is happening. You realize that these other values are even positive. So that means they are higher boiling points. So that means the boiling point increases from methane to decane. So basically that is what we have there. So like I said, I'll continue to emphasize. We are going to you're going to have to rewatch this video in order to understand that part if you're still lost. Otherwise, I feel I have said everything I have to say concerning melting and boiling point. So if you're still not there, please rewatch this lesson and get the point very well. And I will want to encourage us, the more you say something is difficult, the more you're going to find it difficult. And the more you say you're lost, is the more you're going to get lost. So like I said, encourage yourself to have an open mind. I don't want to assume that it's simple, but the kind of mindset you have towards a thing is what is going to help you. So I thought I could share that as we continue with our lesson. So open up your mind to understand and don't join the clue of says I didn't understand. Someone will be saying they didn't understand, yet they have understood. So please endeavor to understand as an individual. It's very, very important. Don't join the I didn't understand clique because you will be alone at the end of the day. So let's always endeavor to open our minds to new things and understand them as well. The person copying notes, I'll share these notes in the group. So the best thing you could do is actually take a screenshot such that you reserve that work. Otherwise, copying takes a lot of time. Those ones asking which topic, I don't know how to help you because this lesson started last week. So it's carbon in life. Okay, so the take homes are basically you understanding that we've looked at the different physical properties of alkanes and we have said number 1, boiling point and melting point increase with increase in molecular mass due to the weak van der Waals forces of attraction. Then alkanes are colorless and odorless. Alkanes having carbon atoms 1 to 4 are gases. 5 to 17, their carbon atoms are liquids. Then 18 and more, those ones are solids. Then we have alkanes are insoluble in water and soluble in organic solvents such as benzene. And then, of course, the density increases with increase in molecular mass, but branching reduces this trend. So basically that is what you have there. So let's continue. So looking at the chemical properties, someone mentioned that they burn in oxygen to give us carbon dioxide and water. Anyone with a group link, please share it in the group such that people are able to join those that are not on the group. So for chemical properties, we know that alkanes basically undergo two reactions. And those two reactions, one of them is combustion, while the other one is hydrogenation. So for combustion, that means you're burning something in oxygen. Then for hydrogenation, it comes from the word halogens. Anyone who knows the examples of halogens that we have? Any examples of halogens that we know? Yes, Vanessa? Vanessa, please unmute and talk.
Madam, iodine.
Iodine, very good. Any other? Frankenstein?
Chlorine, bromine, iodine, astatine, and tennessine. Our teacher said that those ones belong in the group 17 of the periodic table.
Okay, thank you. So but you've said all of them, so now what are your friends going to say? So anyway, we have all group 7 elements are halogens. If you go to your periodic table, all elements in group 7 are halogens. For example, fluorine, bromine, and iodine. So those are the ones that we call halogens. And then combustion, I have said that is burning in oxygen. So I have noticed why some of you are asking the kind of questions you're asking. It's because you were not here in the previous lesson and you didn't watch the video of that previous lesson. So it is very easy on YouTube. Just go and look for the holistic e-learning platform of senior 3 lessons. You will always get those lessons that have been recorded. That's why most of us are lost, because we began from somewhere last week and now today more people have joined us, which is a good thing, but you missed out on last week's lesson. So Ella, thank you for sharing the link. I hope people will copy it and they are able to connect. So I think that's where the whole problem is coming from. Most of us didn't attend that lesson. Otherwise, when you attend that lesson and then you watch this one as well, it's going to make sense and you'll be able to understand. So that's why I think I've taken even all that time to explain those things. So please please use the link. I have not tested it, so I'm not sure if it works or not. So I'm going to move on to the next part. At least I will endeavor to what? To repost the lessons for last week, such that at least you can be on the same page when you join the group. I'll share the link. Let's first pay attention. If that link is not working, I'll share the link as we go on. So looking at the combustion reaction, we are going to look at an experiment of combustion of an alkane. So here we have this diagram. We have a burning candle here. This is our burning candle. So a delivery tube is placed over that burning candle, and then of course it is inserted into a beaker which has a cork on it, and then another delivery tube is connected from that beaker to another beaker, and then of course it has the what? Still, it also has the cork, and then another delivery tube going into the suction. So in the first beaker, we have anhydrous copper 2 sulfate. Who knows the use of anhydrous copper 2 sulfate? I know your teacher must have shared it in senior 1, anhydrous copper 2 sulfate. So at least for it, it's not new. Anhydrous copper 2 sulfate. Then here we have lime water. Okay, so let me see some answers here in the chat. Okay, this one shows Maverick says water test. Okay, so we know that anhydrous copper 2 sulfate is used to test for what? For the presence of water. So since we say that when hydrocarbons burn in oxygen, they produce carbon dioxide and water. So that means in our experiment, we need those reagents that are going to test for the presence of those two to actually confirm to us that those two were actually there. So that means if we have our burning candle, that means that it's going to deliver the moisture into the what? Into the beaker containing the anhydrous copper 2 sulfate. And of course, after delivering it there, the carbon dioxide is going to continue to the beaker containing the lime water. So who knows the importance of this cold water here? Because we realize that our beaker A is inserted into a cold water bath. Why do you think it's inserted in that cold water bath? Okay, thank you, Zaomi. Zaomi is saying for cooling. That is very true. For condensation, that is true. So it's for cooling. So I want us to watch this video, and of course we are going to come back and answer some questions. So please make sure you're paying attention. And I want to thank you for at least today you've not deviated from the main course. Everyone has been focusing at least to post where they haven't understood or even the answers other than the hello highs and things. So I want to applaud you for that. So let's continue to the video. Please listen in because we are the ones going to give the answers to the questions after we've watched this video. So please endeavor to pay attention.
Hi guys, we are going to run an experiment here that will help us identify some of the products of combustion. So let me quick identify some of the parts of the setup I have here so we can know what we're looking at. In the first test tube here, I have lime water. Lime water is calcium hydroxide. I've only got 4 milliliters of fluid in there, which I measured out using a graduated cylinder. I don't have too much in that tube because if we have too much fluid, the bubbles will eventually get up into the motor, and you'll see what I mean later, and will cause problems. So we want to keep that volume small. I have a mark on that test tube to help me see how far 4 milliliters is. In our second test tube here, I have lime water. In our first test tube here, I have a strip of test paper, which is cobalt chloride test paper. It's blue right now, and we'll see what happens. Again, because we want to control and mount it there so if anything changes inside the test tube. I have a candle here. Let's light that. We want to run our experiment for 5 minutes. So I'll let my candle get started so it has a nice strong flame. before I start my stopwatch, I want to start our pump. So I simply connect our wires back here. You can see bubbles happening, bubbles forming there. I'm going to start my stopwatch, introduce that, move our candle under our funnel, and hopefully we are drawing the products of combustion from the candle up through the funnel, through the green latex tubing into our first test tube, continuing through our lime water, through our pump, and evacuating. Let's bring that a little closer so we can see what might be happening in our fluid.
Meet Boreum, your AI-powered research companion. With 170 million papers, 140,000 journals, and millions of patents, Boreum gives you instant summaries.
This experiment aims to demonstrate the product of complete combustion of hydrocarbons. So in this
Okay, so most of you are saying the volume is low, but the volume is complete. So just try to complete the volume of your and listen in carefully, because I think the volume has to do with where they recorded them from. So it's quite hard to increase it. But I hope at least you've been seeing my endeavors to try to increase the volume.
catch the products of combustion. And the products of combustion, because this apparatus is attached over at this side to a vacuum pump, the vacuum should cause anything that's produced over on the far side to be drawn in through this piece of tubing and through this piece of tubing, all the way through this piece of apparatus, which is called the U-tube, and all the way through this tubing. So
We are going to run an experiment here that will. Hi guys. We are going to run an experiment here that will help us identify some of the products of combustion. So let me quick identify some of the parts of the setup I have here so we can know what we're looking at. In the first test tube here, I have lime water. Lime water is calcium hydroxide. I've only got 4 milliliters of fluid in there. I don't have too much in that tube because if we have too much fluid, the bubbles will eventually get up into the motor, and you'll see what I mean later, and will cause problems. So we want to keep that volume small. I have a mark on that test tube to help me see how far 4 milliliters is. In our second test tube here, I have lime water. In our first test tube here, I have a strip of test paper, which is cobalt chloride test paper. It's blue right now, and we'll see what happens.
Okay, so maybe what we have to do, just watch, then I will re-explain what he's saying using my voice, because like I have said, the video,
anything changes
the
inside the test
video's
tube.
volume is low. Because if you look at the volume, I have
Candle
completed
here.
it, but it's still low. So
That's
just
what I
watch,
thought.
then I will
We're gonna
explain
run our experiment for
using the
5
video
minutes.
with my voice.
So I'll let my candle get started so it has a nice strong flame. Before I start my stopwatch, I want to start our pump. So I simply connect our wires back here. You can see bubbles happening, bubbles forming there. I'm going to start my stopwatch. Introduce that. Move our candle under our funnel. And hopefully we are drawing from the candle up through the funnel, through the green latex tubing into our first test tube, continuing through our lime water, through our pump, and evacuating. Let's bring that a little closer so we can see what might be happening in our fluid.
Monster Math presents Addition Below 10. Okay, class, let's begin.
So like I said, I'm going to explain what he was trying to explain here. So when you look at this experiment, remember we are looking at the products of combustion when we burn a candle. So this illustration here is showing our candle. And of course, he's showing us the lime water, which is in this test tube here. And you're going to notice that this lime water is the same as calcium hydroxide. So the calcium hydroxide, I want you to take note of the color. What is the color of that calcium hydroxide? What is the color of the calcium hydroxide? That is the last test tube. What color are you seeing? Banange, blue. Are you sure we're on the same screen? Okay, someone is saying colorless. Okay, so when you look at the calcium hydroxide, it's this last test tube, this side. This one here is the one with the lime water. So then we have our cobalt chloride paper, cobalt 2 chloride paper. It also acts as a test for water, where we could have used calcium anhydrous copper 2 sulfate. We've decided to use cobalt 2 chloride. So in this case, it is going to help us find out if the liquid being released from the burning candle is actually water. So that means in that case, we have two samples. We have the lime water, which is calcium hydroxide. Then we have the cobalt 2 chloride paper, which is blue in color. So depending on our experiment, as the candle burns, releasing those substances is going to help us identify. So when you look at this lime water, the one this side that has bubbles in it, you realize that the gas is being released into the what? Because of course it's being connected to the electrolytic part such that there is that bubbling within the water. But you realize that after placing the candle, there is going to be a change in the colors of the cobalt 2 chloride paper and then of the lime water. So that is what I want you to take notice of. That's why I asked you what is the color of the lime water, because you're going to notice as the experiment goes on the color changes from lime water to being milky. So you realize that this is no longer colorless. This one here, it's no longer colorless. There is that milky color that it has now attained. Then when you look at the cobalt too, you're going to notice that it's turning pink. So from blue, it turns pink because of the presence of water. So the water vapor that is being released from the burning candle is going to turn the color of the cobalt paper, which was initially blue, to pink. And then the calcium hydroxide from colorless to now milky. So you notice that the difference between this test tube here and this one is evident. Realize that this is colorless, this one is milky. While this is blue, this is pink. So that tells us that there was what? Water being released and carbon dioxide gas. I hope at least that is clear. In the last test tube, it was the gas that was being tested. So that means when we are looking, I will take you back to the diagram that we had. This diagram here that we had. So you realize that in the video, there have been, let me just illustrate what was in the video here. So in the video, we had our candle and the delivery tube that was going into a tube that had the cobalt paper, which was blue, cobalt to chloride paper, that was blue. Then, of course, another delivery tube continued to the test tube that had the lime water. So this is the lime water. So that means here we have our candle burning because it's giving off the water vapor. That means the cobalt 2 paper turns from blue to pink, as you have seen in that video. Then the lime water, because of the presence of carbon dioxide, turns from colorless to milky, as you have seen in the video. So according to this experiment here that we have here, I said instead of cobalt 2 chloride, we can also use anhydrous copper 2 sulfate. Anhydrous copper 2 sulfate turns from colorless to blue. So if copper 2 sulfate, you're going to realize that if it was colorless, it's going to turn to a blue solution because of the presence of water. But then when the substance continues, when the vapor continues to lime water, you're going to realize that it carries along the carbon dioxide, which turns the colorless lime water milky. So those are the evidences that actually a burning candle gives off carbon dioxide and water. And we know that chemically a burning candle is methane. So a candle is made up of methane. So when you burn it, it's literally giving you carbon dioxide because it contains those hydrocarbons. So basically, I think that's it about that experiment there. Sorry about the video having a low volume, but like I said, it's from where they recorded it from because I tried to increase the volume and it wasn't going any higher. Okay, so moving on to the next part, we have discussion questions. Identify two major elements that make up hydrocarbons. So let's answer these questions together very fast. Identify two major elements that make up the hydrocarbons. You can put up your hand or you can post your answer in the chat. Which two major elements make up hydrocarbons? Yes, Venus?
Hydrogen and carbon.
Very good. We have
Hydrogen and carbon.
Okay. That is good. We have hydrogen and carbon, and I can see some people in the chat have said the same. Thank you. Then what happened to the anhydrous copper 2 sulfate solution and why? I have explained it turns to a particular color. So who can tell us the original color of the calcium sulfate and why it changes color? Dennis?
Calcium sulfate.
Copper 2 sulfate. I think the question is on your screen. Aren't you seeing it? Dennis, are you there?
I beg your pardon.
The question is on the screen. Didi?
So I think it turns pink due to the presence of the water vapor.
Okay, thank you, but I think you're confusing these two things. I said we have two things we use for testing water. We have the anhydrous copper 2 sulfate. We things down because when you don't write, you're going to error. So as I explain, endeavor to write, because even some people's answers in the chat show that for them they want their own things. Because when I shift to another screen, it takes someone who has literally been paying close attention to actually relate the content of the previous slide to the one that is on the current slide. So as you practice being a genius, please write down the notes as I explain them. So I said there are two reagents we use to test for the presence of water. And someone is saying they don't understand where the water is coming from. Like I said, even at home, just get a candle, place a glass beaker or anything glass. Don't put plastic because it will burn. Just place glass on it. You'll realize something will happen. There are products that are going to be given off. You'll find a liquid in the glass that you didn't put there. So that shows that when a candle burns, water and carbon dioxide are released. So there is nothing like where is the water coming from. Those are the products that are released. For example, when you burn a paper, you don't expect to see that paper again. You're going to see ash. That is the product. So you don't ask where did the ash come from. Because you burnt the paper, the product is ash. So that means even in this case, when the candle is being burnt, we have said there are two products being given of carbon dioxide and water. So I have said there are two reagents that we use to test for the presence of water. We have anhydrous copper 2 sulfate and then cobalt 2 chloride. So I have said anhydrous copper 2 sulfate is originally white. It's a white substance. But when we are testing for the presence of water and water is indeed there, it turns to what? It turns blue. So it turns from a white solution or a colorless solution because now here anhydrous Since it has water in it, that means it's a colorless solution. So in that case, you have a colorless solution turns to a blue solution because of the presence of water. Then if we use cobalt 2 chloride paper, since it is blue, for it turns from blue to pink. So the cobalt 2 chloride paper turns from blue to pink, while the anhydrous copper 2 sulfate solution turns from colorless to a blue solution. So it is that simple. And why does it change that color? Because of the presence of water. So I hope that is now clear to all of us.
Yes.
Okay, so let's continue. So I posted the group chat, the group link in the chat. So just find where it is and join the group if you're interested. Then what other substances? We have explained that. What happened to the calcium hydroxide solution, and give a reason for your answer. What happened to the calcium chloride solution, and give a reason for your answer. Yes, Alden. Alden, you can unmute. There
Calcium,
is a lot of noise in your background.
calcium hydroxide solution.
Okay, let's hear from Juliana. Juliana, unmute and say what you want to say. Okay, so let's hear from Venus.
The calcium hydroxide solution turned from colorless to a milky color.
Okay, thank you. So that is very good. So we say calcium hydroxide is the same as the lime water. So it turned from colorless to a milky solution. Okay, so let's continue. Thank you for that submission. So when you're writing the equation of the reaction, we have calcium plus the calcium hydroxide plus carbon dioxide to give us calcium carbonate, which is the milk solution, plus water. So in this case, that means in this case, we have methane burning in oxygen to give us carbon dioxide plus water. So that is how we know that that is a chemical reaction of alkanes. These people, let's train ourselves that after giving the answer, you mute because there is noise in your background. So train yourself that after giving the answer, mute again. Then if you have another answer, you can always put up your hand again. Okay, so with that said, you already get the use of the ice cold water. We said it's for cooling and or condensing. Alkane and methane belong to the same homologous series. Write the equation when methane burns in oxygen. So I'm going to give us a 3-minute break. So that means at 3:40 we are continuing with lesson 4. I'm just giving us a 3-minute break to take in what we have shared, such that we can continue with our new work. So those with questions, I could take them during these 3 minutes. If you have any questions. Okay, so welcome back from that break. I think we need to continue. So I will share my number before the lesson ends such that you can inbox me because the group seems to be full. That's why maybe most of you are being denied access to it. Okay, so what is the color of crude oil? So among alkanes, we have different fractions. We have other components that are made up of alkanes that we can quickly relate with. So one of them is crude oil. So what is what is the color of crude oil? Okay, there is dark brown to black. Priscilla, which color is that one? No, the current senior 3 has only one group. It has only group A. It doesn't have group B. Okay, black, dark brown. Okay, that is good. So the color of crude oil is thick dark brown or a black liquid. So it can be a black liquid or dark brown. Our next question. What is the other name of crude oil? Fossil fuels is a general term. What is the other name of crude oil? Yes, Alden.
I think it is. I think it is fossil fuels of petroleum.
Thank you. It's petroleum, not fossil fuels. I've said fossil fuels is a general term used for many other components. So crude oil is one of those components under fossil fuels, but it's not. We can't say the other name of crude oil is fossil fuels. So the other name is petroleum, not petro. I saw someone posting petro. So petro and petroleum are two different things. And you will notice that as we go on with the lesson. So the other name is petroleum. Okay, we'll move on to the next question. Why is crude oil known as a fossil fuel? Who can tell us why is crude oil known as a fossil fuel? Yes, Didi.
I think it's because when crude oil is burnt under oxygen, it produces heat and light.
Hmm?
I think it's because when crude oil is burnt under oxygen, it produces heat and light.
That's why we call it a fossil fuel. What is a fossil fuel? Nswaiba? But thank you for your contribution, though I just wanted you to think through. If we say it's a fossil fuel,
I think because it's got from underground.
okay, good try. Namsoke?
Teacher, because it takes long to be replenished.
Butrayo? Husna?
I think it's because it forms from the remains of ancient plants and animals that lived millions of years ago.
Okay, that is very good. So even some people are posted in the chat. So that is very true. We call it a fossil fuel because it's obtained from the remains of plants and animals that decayed millions and millions of years ago. That's the only way we can qualify something to be a fossil fuel. Okay, so it is formed from remains of living things that lived many million years ago. By what process is crude oil formed? By what process is crude oil formed? Ramla?
I think by decomposition of organic matter.
By decomposition. Okay, thank you. Alden?
Crude oil is formed by a natural geological process.
Stella?
I think it's formed from a process called catagenesis.
Okay, thank you. Thank you all for your submissions. So crude oil is formed by that process of decay and decomposition of living organisms for over millions of what? Of years. So you can choose to write decay or decomposition of those living over several years. Your tree decayed 1 year and then you say it formed a fossil. It must be over a long period of time. So you realize that even in Uganda, they're just discovering that there is what? Oil. Yet that oil must have fossil fuels in what? In the ground. So you realize that that decay takes several years. Our assignment, you're going to describe how crude oil is separated into its pure components and use of each of the components. So your take-home is you're going to separate its components and then I use for every one of those fractions of the component. I hope we are together on that. So that is your work. When you're through writing that work, please share with me in my inbox such that I'm able to see. Because of the group, you may not be permitted to share because most of you send messages that are many and they are not related to the work that we give you. So that is the problem. So I said I shared the links, but people say they weren't working. So I'm going to share it again. First try. If it's not working, then send me an inbox. When Mr. Kaziba shares the what? Shares the link, I will be inboxing you. So just inbox me on that group, sorry, on that number. And please don't send hi, hello, because I will not respond. So get straight to the point. Say, good evening, madam, or good evening, teacher Martha. I'm kindly requesting for the link. There I will respond. If you send hi, you will wait for forever. If you send good evening, you will wait for forever. So please press it right, then I will be able to respond to you ASAP. But if you don't want to respond to you, just send me any message that is beyond what I have just said. So please be sure to have that. Just on the number, you inbox me. Then when he shares with me the link for the second group of senior 3, I'll be inboxing you that link and you'll be able to join the group. And that means after joining, I'll be able to share the work, and then also the link for this video will be shared on those groups respectively. So please endeavor to join and also okay, otherwise, thank you for being a good class. Thank you for participating. Those who haven't understood, still I'll implore you to open your mind. Say, I understand these things. When I read, when the teacher teaches, I'm able to understand, because the person who prayed for us to understand. So there is no way God is an author of confusion. It's not possible. So that means if someone prays for understanding, that's why we begin with a prayer, such that you open your mind. These concepts may be new, but they are understandable if you open your mind. Chemistry is not hard, and as long as you're in senior 3, you are all chemists. When you finish UNEB in senior 4 there, you can say, me, I'm a historian, me, I'm an economist. But for now, you are all chemists, and that's how I see you. That means you have the ability to understand the chemistry. And chemistry is a non-living thing. For you, a living thing. That means you have the power over it and you can understand it and excel in it. So never tell yourself you're lost. If you need clarity, you can say, teacher, may you clarify that thing, but don't use words like lost, confused, all those things. They confuse you even more, or you even get lost the more. So I am not stopping us from asking questions, but even when you're asking those questions, please endeavor to do that. Open your mind. The person who is still asking for the link, have you been in this lesson since we started? Because I think I have shared my number and I said contact me on that number to share with you the link, because people have said the link is not working. So chemists, please watch these videos. Those who just joined us today, you're most welcome. So please endeavor to watch the lesson for last week and the lesson for this week, which is this lesson. Mr. Kazbores posts them by 7 p.m. So please endeavor to join those groups, such that even the work we have studied, we post it there, such that you're able to keep track of our learning process. And I'll also encourage us in our next lesson, carry a book and a pen, because most of us ask questions that we have already said, and then you keep asking the same question because you're not writing down. If you're to be trusted with anything, you must be able to note down some things, because you will remember faster than someone who just came to become a spectator. You are not a spectator, you are a chemist, and you should be able to relate with the chemical concepts. Otherwise, thank you so much. I thought I needed to share that in these remaining minutes of the lesson, such that next week when we come, we join in early and we are ready to learn. So let's endeavor to do that. Otherwise, thank you for being a good class and God bless you. See you next week. But I'm waiting for my work, so please endeavor to share the work when you're through. Very, very important.
Abalala baasoma ebyange bye byagaana okukola. Tebonne unmute.
Wanji?
Hello, guys.
Yellow.